Last part of 5 today. And then Tuesday, we'll look at networking addressing. I'm going to do some jumping around there since we're going to miss some time in there. But IP addressing, I guess, really is 7. So yeah, we should be able to do 6. And then IP addressing we'll get somehow and stuff. So I've got 3 days you're going to miss after that. But there is some stuff out there in Blackboard from me on the IP addressing and numbering and that stuff. So the last 2 things we've got left here in chapter 5 is that we've got the switch forwarding, and then we've got ARP. So with switch forwarding, remember it's going to be passing through the switch as it goes along from wherever your first chain was ultimately to the destination. And it's going to bump switches along the way. And the switch is going to look at it obviously on layer 2, and it just looks at the frame on it. And that it will pass it on along. Store and forwarding switching is what was done originally. And then you've got the cut-through switching as another option on it. Now, they both got some advantages to them, and they got a disadvantage to them also to it. With store and forward, that one, the whole frame came in, and then the switch looked at the frame and looked at the address on it and determined if it knew where it was supposed to go and proceeded to go ahead and send it on out onto the destination. That it then, so it opened up the frame, looked at the destination address, fixed it, and did whatever, or just forwarded it on once it determined the address on it. But the whole frame arrives before it does anything. So in the process, it also checks there to see if there's any errors on the frame. It uses that CRC we talked about. And if the frame's not all there, or there's something's been damaged to it, it drops the frame at that point. So with store and forward, it's going to, frames that come out of the switch, we know are all good frames. Okay? Now, there's a delay in the process, though, of waiting to get the entire frame to determine what to do with it. When the information we want, if you remember when we talked about the layout of the frame, where's the destination address located on the frame? Where did it put that address on there?
Right after the preamble.
Right after the preamble. Okay, so it's at the very front of the frame. With cut-through switching, what it does is it goes, all right, here comes the frame coming in, it's seeing the preamble, and then it sees the destination address coming on in, and instead of waiting for the whole frame to get there and determine is it all there, it looks at that destination address and proceeds to forward it on to where it belongs. without waiting to see on the whole thing, and remember that the CRC's on the back end of the frame, and that it couldn't use that to check anyway until the entire frame's there, because that's going to be the way it's going to look at what's encapsulated in there, is that it then, as it starts coming in, as soon as it sees the address on it, it proceeds to start forwarding it out the correct port immediately as it's coming through. So the frame doesn't stop in there. That means it's going to go through faster now, okay? Because there's not a delay and wait for the whole frame to arrive and then look at it and determine where it goes. It goes ahead and looks at it. Now, in some cases, yes, it's got to get the whole thing still because it's got to stop and decapsulate and re-encapsulate it in the process, okay? But in this case, all it's got to do is that it looks at the address and says, okay, I know where I send that one to, and it proceeds immediately to start sending out as it's coming in. So, to use a train analogy on it, the train just rolls on through the station because it knows at that point which split on the train on the rail to continue on and just keeps right on rolling, instead of having to come to a stop and then determine which way to go at that point. It just kept right on going. Now, the problem with that is, so it's going to be faster on it with the cut through rather than storing forward. However, it doesn't check to see if there's any damage. So if the frame has had problems getting there, it's going to be forwarded right on with its problems and sent on out, and so it still stays out there on the network and gets passed on to somebody else. And if this was one that had been involved in a collision, and remember we talked about those and said with CSM ACD that there's going to be collisions, okay? That it then is going to be all those little fragments that are floating around. It's going to be passing those fragments on as long as they're big enough to include the address on there, because it doesn't know if the whole rest of the frame is going to be there or not when it starts forwarding it. So you're going to have more traffic floating around on your network that's bad traffic to offset the increased speed of not having the latency on it, having to stop and then resend it from the switch. Y'all follow on that part? So with the cut through, cut through is going to get you increased speed on it passing along, but we're going to have extra overhead because of it. Store and forward is going to get rid of the bad traffic, but they're going to have the increased latency because it's going to have to get the whole thing in there, look at it, and then send it. And so there's that a little additional delay in there. So when you're setting it up, you got to set it, consider which way you want to do on it, to show the differences in the two. With the cut through, there is fragment free switching versus the fast forward switching. Fast forward is going to do exactly like I was saying, but the fragment free, because with fast forward all it gets is just as far as the address and starts sending. The fragment free is going to go ahead and get the first 64 bytes, so it's going to get more of it and know that it actually gets into data at that point. It doesn't know if the data's really all there or not, but it knows the front end is there, okay? So it knows a fair amount about it and just going hopeful on it. So it's keeping it from being just a little fragments from floating out there that all they had left on them was the preamble and the destination address, that you know there's more stuff there. So with the fragment-free one, it's not literally fragment-free. Is that they have determined that usually when collisions occur and there's fragments floating around from that they're usually less than 64 bytes long. That piece has got to be smaller than that. Okay? So that gets rid of most of the fragments, but it does not mean a fragment couldn't still get forwarded through. Okay? If the fragments were bigger than 64 bytes, they'd still go along, but it's still doing cut through because it's getting it quicker than the other when it decides on it. So you got two major choices on it. One of them, there's two choices within it: the fragment free or the fast forward. Within the cut through. And then the other choice is, it doesn't have any sub choices, it's just store and forward. Get the whole thing, look at it, and then send it. Questions on those? You do get questions on those two things, on that of types of forwarding. That I haven't gone through y'all's test recently, but I know you used to have several questions at least on it, and then certification tests tend to have a number of questions on them on that. So that pops up quite often, which is why I'm spending a little bit more time on it than what they're spending in the book on it, because they've narrowed it down in this book, and I don't know if the test has or not, because I really haven't gone back through, because y'all are on a new version of Cisco, and I haven't gone back into the test to see how these tests look on it. Probably wouldn't. So I'd like to get back into them, but that's lower down on it. The other one is I need to glance on a few things. I need to go look at the end of one of the courses and do a practice test on the CCNA real quick now, because somewhere between when we come back, when I get back from the meeting thing that week, that I'm going to schedule myself to go take the CCNA test one day, because Cisco's given me a 70%, or is it a free voucher? 70% off, I guess it is. It'll only cost me like $20 or something. I don't know. I really don't think I'll pass the thing. I was hoping it was a CCNT one, which I think I can. Pretty sure I can. But it's for the whole test, not half test. So I'm intending to take it and see, but then I may not, since it is a few dollars there, but that's a whole lot cheaper than the normal 150 or whatever it is. But then I'm going in not really expecting to pass on it. Remember, the CCNA test has a passing score of like 85. So, but I was hoping they'd do the other. They talk about full duplex and half duplex again. And about doing that. And remember, half duplex, it's one end can send at a time, and that both ends can't send at the same time. And they mention on that also that the switches and the NICs most of the time can be set to auto negotiate on it, and both ends will see what they can do, or what's the faster one they can do. If they can do full duplex, they go to full duplex. If not, they go to half duplex, depending on the two ends. They'll talk back and forth on it. They mention the auto MDIX right here, which gets into the cabling, because we've talked about that when you attach two similar devices, that it's got to have a crossover cable on it, and that if they're on two different levels, it's going to have a straight through cable. Your switches and your routers typically now have an auto MDIX on the port for that, to handle that. And then you can use either cable on there actually, which most of the time is you're going to use a straight through, because we got lots of straight throughs out there. And that if it needs a crossover, that you don't have to use a crossover cable. That port's going to look at it when you connect it in, and it just has to be on the switch or router end. PC doesn't need it on it because it's going to send its signal out. Switch or the router is going to look at what it's receiving, see which pins is it receiving on, and then it'll set up to use those pins to receive from. So the first thing it's going to do is just listen on both and see where something came in on.
So that gives me kind of a weird thought, is what if you had a switch and a router that both had the auto negotiate, and you plug them in and it sends and it goes, oh, we need to switch, they both switch, and it just keeps switching back and forth and get locked in the loop.
But if you're plugging switch and router together, you should be straight through is what's everybody's using anyway, so that's straight through is what you're supposed to be using on that. So you shouldn't be throwing a crossover cable on there anyway. I'm not really sure what it would do if you did throw a crossover on that with the auto MDIX on both ends.
They get like locked in the loop, keep switching back and forth. I doubt they would. I'm sure they can figure it out.
The question would be, in that case, because they're both going to listen initially, and I don't know on the auto MDIX if it goes ahead and sends a signal at a certain point when it hasn't heard something and something's plugged into the port or not. I'm assuming it would, and they probably set the routers and switches at different time period. Well, there's going to be a different time period on that anyway, because you're not going to plug them in simultaneously. You're not going to turn them both on literally at the same moment. They're not going to come up at the same moment to the same spot in their boot up process where they listen. So it shouldn't be a problem then. That the first one's going to, if they both did send something out then and went to listening, that then they'd be okay anyway. But
You
it
would
could
think
it could get weird.
I bet they've contemplated that though. It's
Mhm.
that, you know, this one, the router overrides the switch.
So that's what I would expect, is that they've already got that built in on, or when you got two switches hooked together. But the main thing it's being used on is the fact, it's designed for is the fact that you can just use straight through cables for everything. Okay, instead of having full crossover cable. So that really the only place you need crossover cables typically now is just to connect PC to PC. And not any longer for switch to switch or router to router. And those have been around. The auto MDIX has been around since I think about 2000, because when I took the Cisco in 2001, they were talking about it as a brand new thing, and it wasn't on the routers we were using, but they were telling us when we bought the latest router, it would be on there. So it had just come out at that point. So that's been 17 years, 16 years now. So pretty much everything's going to have it on there. But do be aware of auto MDIX. I've not ever seen it try to trick you on the letters on it, of having some similar type of letters of choices on it, but that it's clearly some different things on it. And the auto MDIX was, if you knew what that was, even if you couldn't remember if it was DIX or IDX, that wasn't a problem to you, that you could pick it out of what the whole totally different choices were. Okay, and that one I see pop up out there too. Well, that's usually just a question, but do be aware of that one. Because every time I've seen it, I've gone, okay, I know which answer it is. I've got it now pretty well into my head about this auto MDIX, but sometimes I'm not remembering exactly the name on it. I know it's auto something. And where they tell you there that it's auto medium dependent interface crossover. So it's going to look at the type of cable and determine what on it. But still, it's just listening across to determine that, because that's the only way you can determine what the type of cable is. It's got to get a signal from the other end to know what it has done. But what it does in the case of if you've got the way John was just describing, I don't know. All right. This book spends a whole lot more time on ARP than they used to spend on ARP. And they illustrate more, throw you a whole lot of illustrations to it in here. The ARP used to be covered in about the amount of area that we just saw on the switch forwarding. ARP is Address Resolution Protocol. Now, what ARP is going to do is when you send something out, it's going to know, either you're going to tell it the IP address or it's going to find the IP address from the domain name. And we'll talk about that in the next chapters, about how it does that. We mentioned it already, but it's going to use DNS to get that accomplished. Okay, we'll look more detail at DNS, but DNS will take our domain name, switch it to an IP address. Okay? ARP will switch to the MAC address. Now, unless we're on the same network we're sending it to, ARP's not going to give us the MAC address of the ultimate destination. It's going to give us the address to the next stop along the way of what's the next switch to go to. Okay? Or router. That is going to get us the address to that next router runner, but it's going to get us the MAC address for it. The IP address is looking at the ultimate destination. With ARP, what it's going to do is going to look at it, it's going to maintain an ARP table on the machine that it has there of MAC addresses that it knows for IP addresses. So it's going to be a table that matches IP addresses to MAC addresses. Now, the MAC address it has there on it is not in the ARP table, unless it's on our network. It's not actually the MAC address of the destination of where the IP address actually is, but it is the MAC address of the next point on the network, on the internet, getting there. Does everybody follow that? So that when we're going from that location to that location, or we could be going from a switch to a switch, whatever, or switch to a router, whatever, however combination, okay? The ARP table is going to be telling us in terms of the MAC address for the next location, okay? Which will tell us where to go out. It's not going to be telling us where that machine is ultimately down here at the end somewhere after it goes through the cloud. Okay? IP addressing give us that one. It's going to tell us where's the next place to go to as it goes. So it's going to keep changing as it goes. Okay? But it keeps in there, it keeps on the machine an ARP table there that has IP address, the MAC address, and that if it's got one in there, it knows, okay, this is the interface to go out on. So coming out of the switch, it knows which way to go to get to there. Okay?
Yeah, I think we talked about this before, but anytime it has no clue, first time you're going to this particular spot.
It's going to use the default.
Default gateway, and then if that next guy doesn't know, he goes to his
It's
default
default.
gateway.
Mhm.
Right.
So, which is where it's going to do a lot of its traffic. Okay? Until it gets down to where it actually knows about it. But it's going to be sending a lot of the way, defaulting to get there. Because after all, when you send it from this machine as it goes to get out of this network here, there's just one way getting out
It's going
onto
there
the
anyway.
internet. It's probably got to pass through a couple of switches and routers on the way out of our network into ultimately onto the internet, but there's really only one path basically across to that. Okay? So it's going to take it efficiently along the way. Now, what it does once it gets out there on the internet, the different frames may go different routes getting there because they may have picked up something different on themselves. Unless we've got a dedicated connection that we've set up where we're requiring back and forth that it's got a connection sitting straight through. And then they're both going to travel, it's all going to travel on the same path on.
On the school here, you just have like one main line coming in for the whole network for the school coming from your ISP.
Mm-hmm.
And then, of course, that's going to go to a router. And then at that point, do you just use switches or do you have like, I mean,
No.
is there a reason to have another router?
There's more routers.
And why would you do that?
Okay, first off, like for the school, we've got a router on each campus. So we've got one line coming in for all of the campuses.
I mean, just for this campus, let's say.
So then for this campus, there's probably just one router here. Okay? Other campuses, there may be multiple routers. Because I'm not exactly sure how they've got those set up. Because with the multiple building campuses, you may actually have it doing a router within.
But each router goes directly to the ISP, right? There'd be no reason to have like, one line coming in from an ISP to a router and then that going to another router without it going out to the ISP.
No, they would have. So you would have a router coming in where it goes out to the ISP. Okay? And then passing to other routers. But, and that you could have off of that some more router off of that in turn.
Now, why would you do something like that as opposed to just using switches?
So that when this one got it, this could be sending to the campuses. You could do a switch at that point and send off to the various campuses, but you could just route it and keep so that each one of these campuses is separate subnet. Okay. And I'm not sure on that right off which way we've got that. A lot of big businesses I know are going to use this way right here. And you'll then end up with, and depending on how you've got it subnetted out, that you may break it on down so that you, and we may have it to here. Because if you think about it, faculty's on one subnet, y'all are on another subnet.
But you can do that in a programmable switch, though, right?
But in that case, you've got the switch doing routing. Okay? because it's doing layer 2 and layer 3. So effectively got a router there.
Yeah,
Anyway,
I got you.
okay? So that you'll end up with a stub network out here on these instead of just all network. So it could be either one. I suspect we've at least got this approach so that each campus has got its own, but they're all going back to Rome, if I understand our network right. I haven't really seen a detailed map on it. That everything points back to there. And then from there, we go to Atlanta as we go, and pass out onto the internet. So we've got a fiber cable dropping here and here. And then exactly how we get onto going to Rome with the state's network, I'm not sure. I think we're going across regular communication. We're going across shared fiber on that. That's the way I know we used to have back there in the 90s, but I haven't seen it since then, so I don't know for sure on that if that's how the state's still done. I'm sure they do, but I don't know that definitely. But within here of the college is fiber between the locations. We've got dedicated fiber run from here, I think from here actually to Walker, and from Walker to the other from what I remember when they were establishing the communications to here, and we got interrupted at Walker and didn't affect the other campuses. And that's using Parker fiber out of Benwood. So if Rome cuts this, we're all,
Yeah.
okay? If we cut any of these, just us up the end of the line. But like I say, I think if you cut the line to Walker, that's going to leave us straight because I think we're running off of Walker to Rome. I think it's the same way when you go to Rome. Gordon goes to Rome, Hope goes to Rome, and us and Whitfield go to Walker. And that goes back to the fact that where initially where the network was all set up from was those two separate schools, was at Walker and Rome.
And that's kind of off subject. I just always wondered if like a single network would have more than one router. And I guess for security and speed,
But you can better subnet it with the multiple routers.
Yeah.
You can define your traffic down there or on there with the separate router. Because now the only traffic coming out of this section off of here is just what belongs to onto that subnet. So you narrow your traffic a whole lot better. All right, so with ARP is looking to see what's the address to the next one. If it doesn't know the address, that's what he said a moment ago, ask on it, it's going to go to default. There's a default in that ARP table. It's got to be a default there always. Otherwise, you're going to barely be able to do any traffic. You could put static entries into the ARP table, but you're not going to. Okay? So that's going to be in there. It's going to put the entries in there. They're on a time basis, like I've mentioned before, so that they're there for a certain amount of time period. If they've not been used in that amount of time period, it's going to drop them. Now, by use, doesn't mean it's got to have sent something out there again. The fact that it just knows it has used that entry either for having sent stuff out again on it, or B, the more important one is that something's come in from that other end again, and it knows where it came in from. And every time something comes in, it's going to look at it, go, is it in my table? I know where this thing just came from, because it obviously knows the addressing on it. and it's going to add it to the ARP table if it didn't know about it. Or if it's different, it's going to change the entry. Because guess what? The path that it came from before may not exist now. So it needs to update the table at that point, and it changes the time value on it every time of how much time till it dies. And I think it keeps that on the basis of the, it should have, it time records it each time, and then it's going to look at it regularly and look, has it been too much time since it was last time recorded and doing the entries. So it's going to have an actual time recorded on it out there, and look again that if it keeps them for however long period of time, and I'm not sure how long those stay there for, it keeps that information and keeps adding to it. So it's going to build all of that for you. And they show you with illustrations of it going through. But if it doesn't know the MAC address, it will make a request, and then it uses the default if its adjoining sharing device doesn't know about it. But the local device is going to keep an ARP table also. So you're going to have several ARP tables on it. So the switch, they'll send a request to the switch. The switch will either A, it knows it, or if it doesn't know it, it'll actually send out a broadcast and say, anybody know about it? That when it sends out the request, and that if anybody is it, it's going to send back its information. So they show you that one, and on the replies on that one, and they do a whole bunch of pictures for you showing on that as they build through it. And then it's going to, like I say, all right, it's going to store them for 2 minutes in Windows. So Windows will keep its ARP table for 2 minutes and then drops them out of its table after 2 minutes. The others I'm not sure on, but the book specifically tells you on that. And that it does do ARP broadcast on it, which can get to be a problem if you have a whole bunch of devices power up at the same time and make ARP requests all together, but that's not normally going to be a problem during the day. ARP spoofing is a security issue there. It can be called ARP poisoning or ARP spoofing. And that's where it puts out a false ARP address on it, so that stuff gets sent to the wrong location. And that you can get into an ARP table and put the wrong MAC address there for the IP address, and then it's spoofed it to a different location, and the stuff's being sent to the wrong place. So be aware of that one on that. And that there is the end of the chapter. Okay? I'll mention one other to you that they used to mention in the book, but don't have mentioned in here besides ARP. There is RARP, which is reverse ARP, which effectively does, which if you give it an ARP, you've got an IP address to MAC, which is what you normally are looking for. But you could also want to be given a MAC address and want to know what the IP address for it is. RARP will do that for you. RARP goes and takes MAC addresses and gives what the IP address is for that location. Not used very often, but it can be used. So like I say, they used to have it in the books, but now they've removed that little piece from it. They used to have a paragraph or so about what RARP was. But just to tell you that one also. But I don't think you got anything that you got to know RARP for.
Do routers
Well, I noticed like on these, you've got a memory module in here, 32 megabytes or whatever. Do routers come with different amounts of memory, and does that affect the size of your ARP cable or your buffering, or what is the extra memory for?
Actually, that's actually where we're going to store the configuration files. 'Cause that's the storage location on there.
Oh, so that's just like if you want to.
So when you configure that router like y'all have already done,
Yeah.
when you save that or when you copy it, that's where it's saving it to.
So then you just take it to another one, plug it in, and copy it over to it?
So it used to be in the older routers, it was all built-in flash memory for it, and it was using flash memory either way. But if your router died, you had to have had a printed copy of the config file, and you had to re-enter that whole thing on your new router on it. These routers with the external flash memory on it, all you got to do, if that router dies back there, we don't have to worry about trying to figure out if we can possibly get the machine going in some way again. All we would do is pull that flash card off there, get the replacement router, and if we're a larger organization, we've got an extra router sitting there that we just got to stick another router there, or else we got to go buy one and get Amazon to ship it overnight to us. And then all we got to do when it comes in is pull that card, plug it in the other one, and it's got the config already sitting there for it, and it's ready to go. The other thing you will have to do, though, that won't do, though, on it, is that you will have to go in there and tell it to change the MAC address for the router if you're on a larger network. But if you were on a smaller one, that you weren't using any MAC addressing methods on it, slide that in there. And unless the router's got something different about how it configs on it, you may have to make some little repair in it, but basically everything's set for you at that point. And you're off
Does it
and
boot
running.
right off of that, or do you have to then go and enable and then say load that configuration?
It's going to grab the configuration when it boots. When it goes to get the configuration, it's going to grab it off there. Okay? Because that's built into the boot process to go look there for the config file.
What about built-in memory? Do routers come with like different amounts of cache or whatever?
It should be, those are going to be whatever they come with. It's not something you can change on it. And it's very minimal amount of the memory and storage that needs anyway, just like you saw on that storage. That's the entire storage for that router, and it's a 32 meg card. Okay? Because it's only a text-based file. It's always keeping out there's text-based files, so it doesn't use much space at all. Graphical kills your space.
Well, I was just thinking about like the ARP table. I mean, if they could keep a bigger ARP table, then they know more stuff to do.
And you can, but there's only so much stuff you can put in the ARP cable anyway.
Yeah, and it
So you're
clears
not
it out
gonna-
every so often.
That is cleaning it out regularly, so that thing's not going to get real large. Okay?
So memory's not a big deal. on the router.
Memory's not a big deal on a router or a switch. Okay? Memory and storage, neither are a big deal on them. So I really think 32 meg is the size we were using for storage, and are the ones I started using 15 years ago. And even then we were going, it's only got 32 meg in it. Actually, I think it was a little bit smaller, but still 32 meg has not been much for a long time.
Yeah.
Because we were looking at like 200 meg hard drives at that point. So 32 was still small on it. But like I said, you've got a little bit of GUI to it now, but still it's it's very basic GUIs when they build GUIs on them, but they're keeping them very basic and simple. And so it doesn't need a whole lot to it. Think about your GUI on your Linksys or D-Link or whatever routers at home, that when you've gone into the settings on them, or when you went into it in the wireless chapter in here, you went into it, put Linksys wireless router on it. It was graphical, but it's very basic graphical. It's not got any fanciness to it, okay? And that really is if you haven't used a Linksys router before, the interface you saw there when you were doing the wireless there in the previous chapter, that is the interface you get on a Linksys router. So Linksys used to be owned by Cisco. Linksys was a separate company originally when it started. Cisco bought it and ran it for, I guess, about 15 years. They bought it in like 2001. And then they sold it about 2 or 3 years ago, 2 years ago. And Netgear, I think, is the one that owns it now, if I'm remembering right. Is who bought Linksys. Because basically Cisco 2 years ago decided they wanted to get out of the consumer business. So they sold Linksys off and did not find a buyer for the foot camera for the price they were wanting for it, and just shut it down. Which I think somebody should have gotten that one, because the flip camera is nice. It's a small little video camera that does a good little job. Because I like mine. I don't do a lot of video shooting, but I have shots. What I have shot, I've pretty much shot with a flip camera a lot. Right then, just before they shut the thing down. All right, other questions? Of course, you can do the video on your phone now and stuff too, but still, it makes a little bit nicer, better, the phone type approach does. Or like my Canon Rebel does video too, and does a good quality video on it. But the flip camera, I didn't have as big a thing to carry around for doing video. All right, other questions on it? So y'all got, I'm thinking, there's either a question on this chapter's test or it was previous chapter's test about CSMA CD. CA was done in this chapter, wasn't it? So it's on this chapter's test about CSMCA, about that. There's really not an answer there for you, and I have reported it, that it says about the book and the online materials have got exactly the same sentence in them that says that collisions don't occur on switches, and so it doesn't use CSMA because there are no collisions there. And you've got a test question that says, that has an illustration and has a switch in it, and one of the two networks it wants you to choose about is using CA or CD, is a switch connection. So it's a switch network connection right there, which from what the books told you, it doesn't occur. Ultimately, if they don't fix the question, I will give the credit back on that question. So when you hit that one about it, and you're going, not sure which is the right answer, because you're going, there is no answer on this. I'm aware of it, and they are now aware of it. And actually what will happen is that Cisco, if they determine that I'm correct, that they're wrong, and they have determined that before. And I told them, because one student already took the test and told me and pointed out the sentence in the book, and I went, well, I wonder what the online material says, if it says something different. And it actually happened to be identically the same sentence in both of them.
I'm guessing they're going to say it's CD though.
I think it is CD is what they said on it.
Because it's wired.
But So what they will do ultimately, when they determine the answer is wrong, they'll actually go back and just grant credit without even telling you about it, and your score will change. Okay, so I'm going to wait on transferring that one for sure, although I really haven't gotten you transferring those grades anyway. And if they don't, I'll go back and give credit accordingly for that anyway. Although I really don't think, if it gets down to the end, the other part is one question in the course is not going to make a difference on your final grade. Okay? Because for one thing, if you are sitting within a half point of the next letter grade, you're going to get the difference. So if you got an 89.5, you'll get an A in here. Okay? But if it did make a difference on it, you can tell me then that, wait a minute, that if you come up with an 89.49, but usually I've not ever, usually when I've looked at one that's hit like that, because I'll notice the scores as I put the grades down, because I am looking at the score to figure out what letter grade to give. And really, I've probably give on that unless it's somebody that just quit at the end and didn't do the last chapter test or something, and so they've got 69.4, they're going to get the D. If they've done everything along the way, odds are they're going to get a C anyway. So there is, I really do look at the stuff as I'm putting the grades across on it too. Because the other part is I will look and make sure the grades do match, and it does calculate different slightly because of how it does its rounding on Cisco versus Blackboard, and I'll look at both numbers, and usually it comes up with the same number on it, but sometimes they'll be off by a tiny little bit, and you'll get the benefit of doubt if it makes any difference. And that's very seldom it ever makes any difference, but if I see it making a difference, I go back and try to figure out where did it goof it up. And particularly when it makes a bigger difference, I'm going, wait a minute, there's something not transferred across. I didn't transfer across to right. Remember, I'm manually transferring it. So there's a way for me to check to make sure I did type your scores right. So you made an 81 on the test, and for some reason when I transferred it, I turned it into an 18. That will show up at that point because the number will be off, and I'll go back and recheck across and going, wait a minute, everybody else's score in the class matches between the two places, but this one's off by a fair amount. What's wrong here? And I'll go back and recheck every number to see if I transfer them all right. It's not often I make a mistake on it, but I'm not perfect. And then if you end up there and you're going, wait a minute, there was a issue on a question or whatever, and then you see that your score is coming in at that at the very end of the semester, because you'll see both things for a day or two. Because once you do your final, then you'll know what you got out there. Okay, you can write me and tell me, here's my issue with whatever it is. And y'all all know I'm look at what y'all write and respond. You might not win the argument, but I always look at your argument on it. Any questions? Everybody got it? But make sure you take the test by Monday night. Test is out there. Okay. And then Tuesday I will see you. And then I won't see y'all again for 2 weeks. Because I will be at school all of next week. Although Thursday and Friday I won't be on this campus. I'll be in Calhoun at meetings. But then that next week I will be gone the whole week. But I will be online every evening. Probably not till the evening, because it won't be till I get to the motel room each time. And so that means Sunday, most of Sunday I won't be on until late in the evening, probably when I get there to North Carolina. Then on Sunday a lot of times, that's too many books. So, and then I've got the meetings Monday through Thursday, and then Friday will be a travel day again and for the weekend, getting back down to Georgia from North Carolina. So I'll probably go visit some friends in South Carolina or my uncle or something as I come back across. And exactly when I'll be online, I don't know. But I will be every day.
We'll bring back some of that good barbecue they have in North Carolina.
So, no, I'm not going. Hopefully I will get at least a barbecue sandwich up there at some point. Well, they served us barbecue last year for for the dinner they had for us.
Mhm.
And, well, I say I haven't been out to New Bern before, so the other part is I do want to go see the World of Pepsi Bomb there, which isn't supposed to be as good as the World of Coke, but I do want to go see what they've got there. Because that is Pepsi's birthplace. It's where I'm going to. So I'll see what they've got there, but it's not supposed to be anything. They're supposed to have some type of exhibit center there, but it's not supposed to be anything like Coke's got with World of Coca-Cola. And those of you that haven't been to it, it's impressive. They're in Atlanta.
Having grown up in Atlanta, Pepsi's a swear word.
Well, it should be here too, because this is where it came from. Remember that Coke was invented in Chattanooga.
What? I know they're real big in Atlanta. They gave a lot of money to.
But that's where where they originally invented it was here, and then it was developed down there. So then Pepsi's big in the Carolinas, since it did come from the Carolinas. So that'll be the only problem for me is because I'm a Coke person. Although I can drink Pepsi also. Pepsi's too sweet for me.
Oh, it all seems about the same to me.
You can give me a Coke and a Pepsi and I can tell you which one's which, and I can tell you which one's not either one of those.
I mostly just drink water and tea. That's all I drink. If I try drinking Coke now or any kind of soda, it'd burn my throat.
And both of them will be glad to sell you water also, and they'll both be glad to sell you tea too. They both got that in their product lines. Of course, Pepsi will sell you your Kentucky Fried Chicken and your Taco Bell and what's their other one? Pizza Hut. Are all owned by Pepsi. And Frito-Lay potato chips. Well, I guess actually those restaurants aren't anymore because they spun that off because Yum went off separately. But it was part of Pepsi at one time. But Frito-Lay is still part of Pepsi. All right, any questions? Then I will see you Tuesday. Have a good weekend. And good luck on the test.